Okay, guys, this is Miss Harris. I am about to work the practice problems from one of the practice exams from Miss Medder's Unit 1 test, whatever she's calling it. Your questions on your practice test will look similar, but not exactly like these. They're going to mix up the question order, and the only thing they do really is change the numbers. So if you can understand how to work all these, you should be able to make a good grade on your test. Number 1 says, let g of x equal 4x plus 5. Find the g of 7. So everywhere there's an x, you're going to put 7. It's really important to use parentheses. Okay, you can type this in the calculator. That's going to be 28 plus 5, which is going to be 33. You just type it in the box. All right, number 2, determine algebraically whether the function is even, odd, or neither. Discuss the symmetry of the function. First of all, for a function to be even, all the exponents need to be even. Or for it to be odd, all the exponents have to be odd. If there's a mixture, it is neither. This problem has an exponent of 3 and 1. They're both odd, but a constant has an even degree of 0. So we have a mixture of odds and an even. So it's going to be neither. Symmetry, if a function's even, it's going to be symmetrical on the y-axis. If it's odd, it's going to be symmetrical about the origin. Sorry for the handwriting, guys. If it's neither, it's going to have no symmetry. So that's fairly easy. Number 3, let f of x equal 2x minus 1 and g of x equal x squared minus 3. I want you to find the f of g of negative 1. So the first thing we're going to do is use the g function because you work inside out. You're going to find the g of negative 1. So the g of negative 1, everywhere there's an x, you're going to put parentheses. And instead of x, you're going to plug in negative 1. Make sure you got negative 1 squared. A negative times a negative makes a positive. 1 minus 3 is going to be negative 2. Now that's what the g of negative 1 is. So now you're going to find the f of negative 2, because that's what g of negative 1 was. So you're going to go up here and use the f function. And f of x, f of negative 2, f of stuff is 2 times stuff minus 1. I'm getting that from this. 2 times negative 2 minus 1, that's negative 4 minus 1, which is negative 5. All right. Very similar to number 1, except this is called a composite function. You have a function inside of a function. Okay. Number 4. By the way, I know the print on this is very small, so you might want to pause the video and zoom in, or take a screenshot and zoom in if you can't see this. It says graph the function, state the domain and range. So we have the line y equals x plus 2 when x is greater than 1. We have the line x minus 2 for x less than or equal to 1. The one that has the equal is going to be a filled in dot. The one that's just greater than 1 is going to be an open dot or circle. This is the parent function y equals x plus 2, so it should be shifted up 2. So, but we're only wanting that line. Sorry, y'all, that's my dog. We're only wanting that line when x is greater than 1. So, plus 2 would be shifted up 2. So if you were rough sketching this, that is the entire line. Now, we only want that line when x is greater than 1. So if I plug 1 in to this equation, 1 plus 2 is going to be 3. So the point 1, 3, what's going to make it work, should be right there. It's open because not equal to, and you're going to use this part. So as I look down here, that's a closed circle. That's open. That's the wrong line. That's the wrong line. If you were to graph y equals x minus 2, that's shifted down 2. And when x is 1, if you plug in 1 here, 1 minus 2 is negative 1. So 1, negative 1 would be this point, closed, and that. And because we only want that line for x less than or equal to 1, that's that graph. For x greater than 1 is that graph. So the best answer is B. Domain is all reals, or, because they want you to do interval notation, you're going to say parentheses, negative infinity, comma to infinity. Now the domain, remember, is x, range is the y. So x you're looking left or right, y you're looking up and down. Pay no attention to my dog running crazy. The range, if you look at this graph, it goes down forever and up forever, but there's a gap right here. Now remember, this was the point 1, 3, and this was the point 1, negative 1. So there's y values everywhere below 1 or equal to 1. So you're going to say from negative infinity, comma, to negative 1 with a bracket because it touches negative 1. Or union symbol because it says interval notation. Or it jumps up and the y values go from 3, the y value, to infinity. And because it could not equal at 3, parentheses, parentheses. Number 5 says for the given functions, find f of g of x. That is not a times, that's an of. So it wants you to find the f of g of x. So you work your way inside out. You're going to find g of x, which is square root of x. And then you're going to plug in square root of x into the f function. So right here where there was an x, it's going to be 5 times stuff, square root of x, plus 2. There's really no simplifying you can do, so you're going to type this in as 5 square root of x plus 2. Okay, word problem. Remember, word problems are normally not as hard mathematically as others. It's just you got to break down the words. Charles buys factory reconditioned hedge trimmers for $30 each. He sells them online for $56 each. He has a fixed cost of $400 per month. If X is the number of hedge trimmers he sells per month, then his revenue and cost in dollars are given by R of X is 56 times X. That's 56 times every hedge trimmer. And his cost is going to be $30 for every hedge trimmer plus the $400 of fixed cost. Find a formula for P of X. That's profit. And profit is revenue minus cost. And then it says for what values of X is his profit positive. So right here, you're just going to plug in R of X and C of X. The important thing is use parentheses. So P of X is going to be R of X, which was 56X. That's revenue. It's what you bring in. Minus the cost, 30x plus 400. But this needs to be simplified. So you have to minus both of these terms. So 56x take away 30x is going to be 26x and then minus 400. That is the formula for P of X. Now it wants the profit to be positive. So you're going to take this equation, well, this expression, and set it greater than equal to 0. Because we want profit to be 0 or greater. That's positive. So we're going to add 400. That gives me 26x greater than equal to 400. And then we're going to divide by 26, divide by 26. Now, when you divide by 26, 400 divided by 26 is going to be 15.38. Now, you can't have 0.38 of a hedge trimmer. So to make sure your profit is 0 or greater, we have to round up. No matter what this number is, we're going to round up to the nearest hedge trimmer. So X is going to be greater than or equal to 16. And that goes right here. All right, number 7. Construct a function that expresses the relationship in the following statement. Use K as the constant of variation. The volume of a gas, so volume of a gas in a cylinder, P, is inversely proportional to the pressure on the gas, S. So if something varies directly, it would have been P equals K times S. But this is not direct variation, it's inverse. So it's going to be P equals K over S. That shows inverse. And then the only choice here is D. Okay. Number 8, graph the relation, determine the domain and range, and whether the relation is a function. The parent function here is square root of x, which looks like this, and then it's shifted down 2. So our answer is going to be D. Now domain, it does not go left forever, right forever. Remember, domain is x. It goes as far left as 0, and it touches when x is 0. So 0, comma, to infinity. It goes right forever. The range or the y values, now, it goes up forever, but it's not going down forever. It's only going down to that -2. So we're starting at -2, and it goes up forever to infinity. Is y a function of x? Yes. Now, to be a function, it has to pass the vertical line test. So the vertical line test is where you take an imaginary line, like your pencil, and drag it from the left to the right. As long as the line only touches your pencil once at any given time, it is a function. Also, if you were in pre-cal last year, and you remember the families of functions, anything that's from the family of functions is a function. All right, number 9, write the function whose graph is the graph of y equals absolute value of x. That's the parent function. But is translated, remember translate means you're going to add or subtract. 4 units left is x, and 1 unit up is y. So with x, 4 units left, you think you would put x minus 4 in there, but it's the opposite. It's x plus 4. And then 1 unit up and down is y. So at the end, you're going to say plus 1. You could also graph this, like graph the original and graph this on your graphing calculator. Put this in y1 and this in y2, and double check that it's going to be 4 units left and 1 unit up. Remember, to get to absolute value, you're going to go alpha, Windows, number 1. But that'll just help you double check it. You really shouldn't need to use the calculator. Okay, number 10. Let g of x equal 2x squared plus 4x plus 5. Find the g of p plus 3. This is probably one of the harder questions on this whole test. So you might want to leave this one for last. That is my dog running crazy through the basement. Do y'all hear that? He's wild. All right, so find the g of p plus 3. Everywhere there's an x, we're going to plug in parentheses and put a p plus 3. So we have 2 stuff squared. What is the stuff? P plus 3. Plus 4 times stuff, p plus 3, plus 5. Now, you cannot just distribute the power of 2. You have to FOIL this out. You got to multiply the binomial times itself. So you're going to FOIL or distribute twice. First times first, outer times outer, inner times inner, last times last. Now this 2 is out front multiplying to this entire product. So p times p is going to be p squared. P times 3 is 3p. And then when you do 3 times p, you're going to have another 3p, which makes 6p. And then last times last, 3 times 3 is 9. You can go ahead and distribute this, the 4. And now we want to distribute the 2 and combine like terms. Get down, Chance. Sit. Sit. Sorry. 2, we're distributing. So 2 times p squared is 2p squared. 2 times 6p is 12p. 2 times 9 is 18. Bring down the plus 4p, bring down the plus 12, and the plus 5. So we're looking for like terms. Nothing is like 2p squared. 12p is like 4p, though, and that makes a total of 16p. And 18 is like 12 and like 5. 18 plus 12 is 30. 30 plus 5 is 35. And your answer, this is up here, is going to be 2p squared plus 16p plus 35. Now, number 11 gives you f of x is x squared minus 16, and g of x is 4 minus x. It wants you to find f minus g of -4. The easiest way to do this is to plug -4 into the g equation, -4 into the f equation, and then subtract the 2 answers. So let's find the f of -4 first. Everywhere there's an x, we're going to put parentheses, and instead of x, we're going to put in -4. Well, -4 squared is going to be 16, and 16 minus 16 is 0. Now we're going to find the g of negative 4. So everywhere there's x, we're going to put in parentheses and negative 4. 4 minus a negative 4 is 4 plus 4, which is 8. Now it wanted you to take f minus g of negative 4. So we're going to take f of negative 4 minus g of negative 4. 0 minus 8 is negative 8. And that goes right there. Number 12. Sketch the graph and state the domain and range. Identify any intervals on which the function is increasing, decreasing, or constant. Okay, so hopefully you can see this. Hopefully there's not a glare. Get back, Chance. If you want to go to your y equals and graph this, you're going to hit y equals, clear out anything that's in there. Go alpha, y equals, make a fraction. And in the numerator, we want absolute value of x plus 5. Alpha window number 1, x plus 5 over x plus 5. Now, if you zoom 6, you'll notice this is the graph. Oh, y'all, my batteries just died. This is not going to be good. All right, so anyway, it looked like this graph. Not a V, although it does have absolute value, but you're dividing. Notice here we have a restriction on the domain because x cannot equal negative 5. If x is negative 5, negative 5 plus 5 is 0. You can't divide by 0. So this is x equals negative 5, and there's no y values. But if you graph that on the calculator, you'll notice that you have this line right here, which is the answer. This one is backwards. The left hand of it was above, and the right hand was down below. That is not what the graph was. And this is over here at positive 5 instead of negative 5. So that's why A is the answer. Now the domain is going to be x equals all reals except for negative 5. Now I want you to use, I'm going to use interval notation for x. And we're going to go from negative infinity to negative 5. But we can't equal negative 5, so parentheses or union, negative 5 to infinity. Hush. Choose the correct choice, fill in the answer box to the range. Now there's only two y values here. It's going to be negative 1 and positive 1. So you're going to put this in as a set, negative 1, comma 1. And it already puts the braces there for you, so you're good. The function is neither increasing or decreasing. It is constant over an interval. So it's constant from negative infinity to negative 5 or negative 5 to infinity. Oh, now, look, it says use a comma to separate the answers. I used the U. That's going to count that wrong. So make sure you use a comma. Make sure you're reading the directions. Number 13, the function f of x is 1 to 1. Find its inverse. Inverse means opposite. So what you're going to do is switch x and y and solve for y. So this used to be, f of x, remember, is y. So that used to be y, so now it's x. Equals 4 times x. It used to be x, now it is y. And we're going to solve for y. So we swap x and y, and now we solve for y. So we're going to add 5. And then we're going to divide by 4, divide by 4. And that is not just any y, that is the inverse. So that's what this notation is f to the negative 1 means inverse. You're going to type this in right there. Again, remember, you can pause, stop it, rewatch it if something's confusing to you. Number 14, determine whether the pair of functions f and g are inverses of each other. Now, when they give you a graph for a function to be an inverse, it has to be symmetrical across the y equals x line. Here's the y equals x line. So as you can see, if you were to crease the paper right here, this graph and this graph are mirror images, so they are symmetrical. So yes, these are inverses. All right, 15, they give you a set of ordered pairs and it says find f to the negative 1, find f to the negative 1 of negative 4, and find the f to the negative 1 of f of negative 2. f to the negative 1 means inverse. So to find the inverse, all you're going to do is swap the x's and y's. So you have a set of ordered pairs connected with commas. And all you're doing is swapping the x's and the y's. All right, so that goes in this first place. Second part of this question is find f to the negative 1 of negative 4. So what this is saying let x equal negative 4. For the inverse, then what does y equal? So you're looking at the inverse when x is negative 4, y is negative 2. And this wants you to find the f to the negative 1 of f of negative 2. These cancel because they're inverses. So basically, it wants you to let x equal negative 2 and put it back in the original function. In the original function, when x is negative 2, y is negative 4. All right. Number 16. Shown on the grid is the graph of y equals the absolute value of x minus 7 minus 7. Use the graph to solve the inequality. The absolute value of x minus 7 is greater than 0. So it wants to know where y is greater than 0. So y is greater than 0 anywhere from 0 or above the y-axis. So it's here and here. So what x values is that? Okay, because we want to know we're solving for x where the function is greater than 0. So from negative infinity to 0. And there's no bracket because it says greater than 0. If it had an equal to, you would have bracket right here. And then it is 0 or greater from 14 to infinity. And it says interval notation, so you use a U, 14, comma, infinity. Not equal to here, so parentheses. All right, 17. The pressure exerted by a certain liquid at a given point. So pressure exerted at a given point varies directly as the depth in the point beneath the surface of the liquid. The pressure at 60 feet is, so pressure is 300 pounds per square inch. What is the pressure at 10 feet? Okay, there's a few of these direct variation problems on here. So it's first it tells you the pressure varies directly as the depth. So pressure equals K times D. That's direct variation. Now, it's not asking you to find K. It's giving you depth and it's giving you pressure and then wants you to find the pressure at a different depth. So if you were to solve this for K, you would divide by D. So pressure over depth is equal to pressure over depth. You're going to set up a proportion. The first given is the pressure at 60 feet. So 60 is D, the depth. The pressure is 300. What is the pressure? We don't know when the depth is 10. So 300 over 60 is going to be 5. And then to solve for P, the pressure, you're going to multiply by 10. So at 10 feet, the pressure at 10 feet is 50 pounds per square inch. Okay, number 18. Determine whether the first variable varies directly or inversely with the other variable. Write a formula that describes the variation. It says the area of a rectangle with a length of 30 inches, the width of the same rectangle. How are they related? Well, area is going to get bigger as the width gets, or the length gets bigger, or the width gets bigger. So it's direct variation. The first variable, area, varies directly as the other. And if area varies directly as width, see, that's direct variation, and it's telling you the length is 30, so that is your formula. And I think they're just going to change the numbers on that on the test. All right. Determine whether the given function is invertible. If it is invertible, find the inverse. So the first thing for it to be invertible, each y can only have one x. Each y can only have one x. This is also the horizontal line test if you wanted to graph it. So each y occurs once, so it is definitely invertible. And so the inverse is going to be where you switch x and y. And that's it. Put those there. It already gives you set notation, so you're using ordered pairs with commas. Okay, if A varies jointly, now that's the same as direct as L and W. So right now, area varies directly or jointly as L and W. And it tells you A is 150 when L is 1 and W is 5 radical 2. What is A when L is 2 radical 3 and W is a half? So it's not wanting you to find the constant. So what we're going to do is solve for K. So you're going to divide by LW, divide by LW. So area over LW is equal to area over L times W. In the first scenario, the area is 150. The width is, the length is 1, and the width is 5 radical 2. What is A? We don't know A. When length is 2 radical 3, and W is a half. So if you reduce 150 over 1 times 5 radical 2 is 150 over 5 radical 2. Over here, when you reduce, half of 2 is 1, so you're left with area over radical 3. To solve for area, you're going to multiply both sides by radical 3. Now, when I do that, I have 150 times radical 3 over 5 radical 2. 150 over 5 is going to be 30 radical 3 over radical 2. And that would be the answer, but you can't have a square root in the denominator. So we're going to rationalize. So we're going to multiply the top by square root of 2 and the bottom by square root of 2. So that's 30 times square root of 3 times square root of 2 is square root of 6. Square root of 2 times itself is square root of 2, which is 2, because it's the square root of 4. And 30 over 2 is 15 radical 6, which is your answer. All right, 21, determine whether the function is 1 to 1. This is where you're going to do the horizontal line test. So you can see if I draw a horizontal line on this graph, it touches my horizontal line twice at any given time, or at one time. So it's not 1 to 1. Fails the horizontal line test. All right, 22. Let f of x equal square root of x and h of x equal 1 over x minus 3. Find f times h and its domain. So f times h, square root of x times 1 over x minus 3. Square root of x times 1 is square root of x. This is over 1, so 1 times x minus 3 is x minus 3. That's your function, which is choice C. It wants to know domain. Now, there's 3 things you can't do in math. First thing is 3 things you can't do. First thing is divide by 0. Second thing is take the square root of a negative number. And the third is take the log of 0 or the log of a negative number. So the first thing I notice is divide. We can't divide by 0. So when will x minus 3 be 0? Because we don't want it to equal 0. So we add 3, and x cannot be 3. Because 3 minus 3 is 0, and you can't do that. Also, we can't take the square root of a negative. So what's underneath this radical, x, has to be greater than or equal to 0. It has to be 0 or greater. So x needs to be greater than or equal to 0, but it can't equal 3. So we're about to put it in interval notation. So equal to 0 means bracket 0, comma to 3, but can't touch 3, or 3 to infinity. All right, number 23, use transformations to graph the following function, state the domain and range. All right, the parent function is x squared, which is a parabola. It's going to be moving left 2, up 3. So left 2, up 1, 2, 3. When you click on this to graph it, you're going to select the parabola. And then you're going to plot this point. So you'll left click. And then the next point's going to be right here. And if you just click it, it should make the parabola for you automatically. Domain, it goes left forever, right forever. Remember, domain is x, range is y. So negative infinity to infinity. But the range are the y's. So the lowest it goes is 3. And it goes up forever. So 3, comma, infinity. Number 24. Determine whether the given equation defines y as a function of x. Now, you should notice that this is x equals the absolute value of 10y. If it had been y equals the absolute value of 16x, we would have had an absolute value like that. But since it's x equals y, we have an absolute value that looks like this. Can't graph this on the calculator, by the way, because it's x equals, not y equals. So what we're going to do is, it wants to know, is it a function? So you're going to do the vertical line test. And you'll see that it fails the vertical line test because it touches the vertical line more than once at a given time. So it's no. Remember, this one will be yes because it passes vertical line test. This one's no. All right, last question. Determine whether the relation is a function. To be a function, each x can have only one y. Each x value can have only one y value. So the first thing you're going to check is, do any of the x's repeat? 8, -2, 1, -5. They don't, we have a function. Now, if it had been this, 8, 5, -2, -5, 1, -2, 8, -8, this x and this x repeat, and that given x has two different y values. So that would be not a function. Okay, guys, that's the end. I've done one of every question. You should do the practice test over and over until you can get 100 on it. Should be the same questions, just different numbers. Best wishes.